So guys, welcome to our channel once again. In today's video, we have here these 9 questions to answer on the topic electromagnetic fields. So guys, this video will be about motor generator effects. So in short, stay till the end of this video as this is a very important one. So let's go ahead and consider the first question here. It says, the purpose of commutators in a direct current motor is to A. Enable a uniform couple to act on the coil. B. Increase the efficiency of the motor. C. Reverse the direction of the current after every half rotation. D. Increase the number of rotations per second. So guys, the answer to this question is option C here, and that's to reverse the direction of the current after every half rotation. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 2 here. It says, a wire of length 30 cm is moved with a speed of 2 meters per second at right angle to a magnetic field of flux density 0.40. Calculate the EMF induced in the wire. So guys, if we use the formula, EMF is equal to BLV sine theta. So we're going to have that since B is given here already as 0.4, L is given here already as 30 cm, that's like 0.3, that's 30 over 100, 0.3, and then V is given here already as 2 meters per second, that's the velocity. Then sine theta is sine the angle, and here the angle is right angle, that's 90 degrees. So if we impute all these together in the equation with the values, we are going to have that EMF is equal to 0.4 times 0.3 times 2 times 1, and guys, this will give us 0.24 volts, and that's option B here. So guys, option B is the answer to this question. So let's go ahead and consider the next question, guys. So that's question number 3 here. It says, an electric motor converts A. Electrical energy to mechanical energy, B. Mechanical energy to electrical energy, C. Mechanical energy to sound energy, D. Electrical energy to thermal energy. So guys, option A is the correct answer to this question. An electric motor converts electrical energy to mechanical energy. So that's it for this question, guys. Let's go ahead and consider the next question. So that's question number 4 here. It says, a device that converts mechanical energy into electrical energy is A. An induction coil, B. A transformer, C. A dynamo, D. An electric motor. So guys, the answer to this question is option C here, and that's a dynamo. So let's go ahead and consider the next question, guys. So the question here is question number 5 here. It says, which of the following devices works on the principle of electromagnetic induction? We have A. Simple DC motor, B. Moving iron ammeter, C. Carbon microphone, and D. Electric heater. So guys, the answer to this question is option A, and that's the simple DC motor. The simple DC motor works with the principle of electromagnetic induction, and that's it for this question, guys. So let's go ahead and consider the next question. That's question number 6 here. It says, a transformer has 400 turns and 200 turns in the primary and secondary winding respectively. If the currents in the primary and secondary windings are 3 amps and 5 amps respectively, calculate the efficiency of the transformer. So guys, let's go ahead and solve these out together. So let's recall that the efficiency is going to be the power P for the secondary over the power P for the primary times 100%. So if we do this, we are going to have that the power is actually the current times the number of turns. So we're going to have current of secondary, that's I of secondary, times the current times the number of turns for the secondary, that's the N for the secondary, over the current for the primary, that's I for the primary, times the number of turns for the primary, that's N for the primary, then all times 100%. So when we do this, we are going to have that current for secondary here is actually 5 amps, and the number of turns for secondary is 200, so that's 5 times 200 over 3 times 400, all times 100%. So when we do this, we are going to have 83.3333%, and that's 83.3% here. That's option B, guys. So that's it for this question. Let's go ahead and consider the next question. So guys, the next question here is question number 7 here. It says, an electric motor is a machine that converts A, high voltage to low voltage, B, low voltage to high volume, C, mechanical energy to electrical energy, D, electrical energy into mechanical energy. So guys, option D is the answer to this question. An electric motor converts electrical energy into mechanical energy. And that's it for this question. Let's go ahead and consider the next question, guys. So here we have a diagram, and the question here says, which electricity device does the diagram above illustrate? We have A, DC motor, B, AC motor, C, AC generator, and D, DC generator. So guys, the answer to this question is option C here. This is an AC generator, and that's it for this question. Let's go ahead and consider the next and last question, guys. So that's question number 9 here. It says, Fleming's right-hand rule is also called the A, dynamo rule, B, motor rule, C, thumb rule, D, screw rule. So guys, the answer to this question here is option A, and that's the dynamo rule. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below, and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.